So hello everyone, we are team number 92 from VIT University, Vellore, and we are demonstrating a multimodal biometric authentication system. A biometric authentication system is basically a security system which uses biometric traits of a person. These could be like face, iris and fingerprint in our case. And since each of these features is unique to a person, the chances of fraud are minimized. And such a system will also do away with the need for tokens and password which could be lost, stolen or forgotten. So here we have a camera for face, which is one of the modalities. The second modality is finger. We are unable to demonstrate the iris modality due to the lack of availability of a iris camera, autofocusing camera. So our primary hardware here is the BeagleBoard XM, and it uses DM3730, which is this chip, DM3730 chip, and which has got a ARM A8 Cortex from Texas Instruments. And apart from this, it has TPS65950 chip, which is also a power management chip and provides other interfaces. The BeagleBoard is equipped with 4 USB ports, which can be seen here, and out of which 3 of them have been connected. It has one Ethernet port, and it has one RS232DV9 connector, and it works on a power supply of 5 volts. For the output, we have an S-video output for an analog output, and for a digital output, this, as you can see, is a DVI-D port, and this is the DVI-D controller. We are not using a DVI-D port due to cost constraints here. So here we have the S-video cable, which is connected to our projector, and this projector is projecting the screen on the wall. And there is a MMC card reader here. I'll focus from the side. So as you can see, this is the MMC card reader, and we have installed angstrom distribution on this. And so for our interface devices, we have this fingerprint sensor. It is a 500 dpi sensor from VIT Technologies. It is the model number is WM100, and it is connected serially. You can see the serial cable here, this black colored cable, and it has been connected along to another cable here, which connects to the BeagleBoard on the serial port. And we have the camera here, and this is a VGA camera, and we were unable to use the leopard imaging board due to the lack of a lens system provided with it. However, we are getting better clarity with this camera, and we are just using this. And yeah, and we have this OMAP DM3730 here, which is a 1 GHz ARM A8 processor, and we have connected to our BeagleBoard a keyboard and a mouse here. So we get a sort of a mini computer on a system that we have here, but which could be portable and can accommodate our system. So now we'll move on to demonstrating our system here, and for that we have a test subject here. Currently, for a biometric system, we need the users who should be authenticated to be enrolled into the system, and a person who is not enrolled into the system should not be authenticated, and thus depart from entering into the system. So this person sitting here right now, he's not authenticated into the system, and when he tries to give his information, he will be denied access because he's not enrolled into the system. So we'll demonstrate here, and as you can see the light glowing, so he's taken the fingerprint input, and the camera is automatically started. So you can see his face on the screen, on the projector screen, which is shown here, and you can see now the photo has been clicked, so it's very still. And now you can see the black colored box around his face. And this is the extracted face. And and you can see our algorithm for face recognition is compensating for the tilt in his face, and yeah, parallelly we've captured the fingerprint. So that has been this is the fingerprint image that has been taken, and this is the thinned image after applying the fingerprint algorithm, and these are the extracted minutiae. So as you can see here, we have these are the score values. These are the score values that were taken from a database, and this is the value for fingerprint, and the face score is this, and you can see here these are the mean and mean values and standard deviation values which have been calculated for fingerprint as well as face, and this is primarily for the normalization algorithm that we have used. And finally we find that the person is not found in the database because it is less than a particular threshold that we have set. And now we would demonstrate that after enrolling this person, this person will be authenticated. So now we'll demonstrate the process of enrollment. So again, he's input his image of the fingerprint from the sensor, and this is from the camera. He's taking his image, and now the image has been taken, and so now you can see again the detection part that's been done, and this is being extracted. So now you can see here, this is the LBP image, the local binary pattern on which our algorithm is based, and it is supposed to take care of the varying illuminant conditions and the face detection and the tilt in the face. And this is the fingerprint image of the person who was just taken in, and so now we have here, and these were the minutiae that were extracted and thinned. So we have successfully enrolled this person into our system now, and now we will demonstrate him being authenticated this time. So as you can see, he inputs his fingerprint image via the optical sensor again, and he's sitting here, and we have via the input camera he'll take in his image. Now he's taken his image, now the face will be detected as usual. The black box will show you that the face has been detected, and this is the extracted face image. And now it has finished extraction. It is calculating the local binary pattern, spatial histogram and chi-square values. This you can see is the fingerprint image. You might have noticed that the fingerprint image in our case is inverted, but that is purely because of the acquisition system, but during our processing we invert the image by 180 degrees. And now these are the minutiae points of this person, and this is the thinned image, corresponding thinned image, and now you can see that this person is authenticated successfully, and we can see this is the final score value that we have obtained from the fusion value. So this incorporates both the face as well as finger value. We have the mean and the deviation values from the database, and so this has been stored, and we have successfully demonstrated the multimodal biometric system by the use of face, fingerprint, and iris. We have not been able to show because of non-availability of the iris camera,